The next case of 5 electron densities that I'm going to discuss, it's going to have 2 lone pairs and 3 bonding pairs of electrons. So there will be 3 bonds, and on 2 sides there are going to be 2 lone pairs. The basic shape is exactly going to be the same. There would be 5 electron densities and the shape would be exactly the same. 3 bonds in a fan-shaped circular manner, in a planar manner, trigonal planar shape. Angles would be 120 degrees, and 1 bond sticking out from the top and one at the bottom. So the basic shape would be exactly the same. So the example that I'm going to pick is the example of this molecule over here, ClF3. Now, in this molecule, Cl is in group 7, so it has 7 outermost electrons in its outer shell, valence electrons, and it's making 3 bonds. So there are, out of 7, 3 are making bonds. So there are 4 electrons left, so 2 lone pairs are left. So the basic shape would be exactly the same. So I'm going to pick this shape and I'm going to work with this shape first. So I'm going to copy this and bring it over here, and now I'm going to try and fit this molecule ClF3 onto this shape. So let's remove this X over here. This would be chlorine. So this would be chlorine, and 3 fluorines would be bonded to this chlorine. So on 3 sides there's a fluorine bonded, and on these sides, this side over here and this side over here, there would be electron densities, but they would be lone pairs. So I'm going to rub this off. And I'm going to put a lone pair in its position. So there's going to be a lone pair over here, and I'm going to rub off the other bond over here. There's no more a bonding pair of electron over there. There's going to be a lone pair on that side as well. And remember that lone pairs do not count in the shape because there's nothing attached to the other side. So there are only 3 fluorine atoms bonded. The basic geometry is exactly the same. The lone pairs are not counted in shape. So the angles and the shape of the molecule would be, this is called a T-shaped molecule. 1 fluorine pointing upwards, 1 fluorine pointing downwards, and 1 fluorine in the middle pointing sideways. So it's going to be a T-shaped molecule. So this is a T-shaped molecule, and all the angles are going to be 90 degrees. So all these angles are going to be 90-degree bond angles. So just to make this picture clearer, I have a 3-dimensional model. This in the middle would be chlorine. So that is chlorine, and there are 3 fluorines bonded to it, and it's going to be a T-shaped molecule. All of the bonds would be making 90 degrees with each other, and there would be 2 lone pairs, one on this side, one on this side, around this chlorine atom. So it's going to be like this. The basic shape was exactly the same with 5 electron densities, but since lone pairs are not counted in the shape because there's nothing bonded to this side or this side, so they would be counted when you're talking about the geometry of the molecule. So this is how ClF3 is going to look like.